Hi, I'm Shyam. I'll be presenting our research applied UAV path planning for inspection through demonstration. In the recent years, UAVs are increasingly used for the inspection of large structures like bridges, wind turbines, airplanes, and so on. The inspection is usually carried out by an expert UAV pilot who maneuvers the UAV around the structure. But UAV pilots are limited in availability, and hiring one can be expensive. To overcome this, automation of the task has been proposed. Numerous methods capable of generating path to inspect a specific kind of structure has been proposed, but these methods cannot be scaled for various kinds of structures. On the other end, coverage-based methods which generates paths to inspect the complete structure have been proposed, but these methods cannot be tuned to inspect a specific part of the structure based on the requirement. In this research, we focus on generating paths for inspection based on demonstration by an expert pilot and extrapolate it for inspecting all objects of similar kind such that the new trajectory inspects the same part or regions as a demonstrated one. In this method, we give the CAD models of a structure along with the trajectory to inspect it and the model of the structure for which a new trajectory needs to be generated as inputs. As a first step, we convert the two models into point clouds and compare the similarity using iterative closest point matching (ICP). We proceed further only if we find similarity between the models using ICP. Then based on the overlap estimated using the ICP, we estimate the correspondences between the similar regions in the two models. Following this, we estimate the visibility, that is the regions on the structure that are visible or inspected by following the demonstrated trajectory. Then, the demonstrated trajectory is subsampled into inspection viewpoints, such that every inspection viewpoint can view certain percent of the structure that was not visible from the previous inspection viewpoint. Then, using the mean and the standard deviation of the point clouds of the demonstration in the target models, the inspection viewpoints are translated to inspect the target model based on standardization in z-space. Finally, the new trajectory estimator is optimized using Gauss-Newton method by using the distance between the inspection viewpoints and the points on the surface of the model in the demo and the target model as residuals. This finally gives us the target trajectory, which is used for the inspection. Here, we show demonstration trajectories for inspecting the fuselage, wings, and engine of an Airbus A320 model. Using the same, we compute similar trajectories for Airbus Beluga, B777, and B747, which have different geometries and scale. Following are the demonstration and target trajectories for inspecting the tower of various wind turbine models. These are the demonstration and target trajectories for inspecting the hull of various ship and yachts. Here, we show the demonstration to inspect the engine of an A320 airplane model in action. Based on the demonstration, trajectories to inspect engines of various different airplanes were estimated. We also validate the model in real world. We use a bridge-like structure and an 8-like trajectory to inspect the columns of the structure. Here, the expert UV pilot flies in an 8-like path around the structure and inspects the columns of the bridge. Following this, a target trajectory was generated, and the UAV flies autonomously in an 8-shaped path across the columns of a bridge-like structure, inspecting it pretty similar to the demonstrated one. Thank you for listening to my talk. In case of any questions, feel free to reach out to me in the contact details provided.